So in this video, we're going to look at three carboxylic acid derivative chemistry, that whole chapter, three mechanism problems where you're asked to just draw the mechanism. For this one, I have an acid halide and a, what is this, 1-methanol benzene something, whatever you name this molecule, you're reacting it with that. So you're asked to draw the mechanism. So how do you do it? Let's begin. Try this on your own if you'd like, but it starts with this here, and we could use base like pyridine to deprotonate this, but in this case, we don't have a base, but we do have this molecule here, which, you know, if we wanted, we can take another equivalent of it, and I'll actually just draw that here to deprotonate this, so then we can react it with a more stronger nucleophile, so to speak. So usually you'd use pyridine, but in this case we don't have that in this problem, so we'll just deprotonate it by another one of our reagents. So we go ahead and we attack the carbonyl, and we push up electrons, and we'll see that what an ugly drawing I have created. This is like the ugliest molecule ever. Anyways, so the next step is to just simply kick off the chlorine by arrow pushing, reform the carbonyl. Chlorine's an okay leaving group. Or I should say, it's a good leaving group. It's like, okay, I'll leave, that's fine, bye. But this is our final product here, and that's the mechanism. Very simple. Let's get into the next problem. So for this one, we have a primary amine, and then we have an anhydride. So how will this react? There wasn't an acid or base catalyst given in this problem, so we'll just assume it's happening under neutral conditions, which is okay. Might not happen as fast, but hey, what can you do? So the first step, and I'll actually draw this arrow less because it doesn't need to be, and we need to save room because this mechanism will be quite lengthy. Our amine is going to just attack one of the carbonyls, push up electrons, and we get this here, and I'll actually draw, this is going to look cursed. Like that, yep. So I'm not drawing it very conventionally, but I'm trying to make room for our amine because that's where most of the chemistry will happen. So we have 1, 2, 3, yep. Okay, so this is our compound here. Notice we have a positive charge on the amine, the negative charge on the oxygen. Now, it could simply kick off the amine and go back, but that's not what we're interested in here. We're interested in the forward process. So we'll get deprotonation first by H2N, and then I'll just say R, just to not draw out that whole thing again. So it's going to steal a proton, give it back to nitrogen, and we'll get, and I'll draw it normally this time. I keep flipping the molecule, I'm very sorry. And we have oxygen, and then we have N, H, 1, 2, 3. Okay, so we have this molecule here. Nitrogen's now okay. Assuming this is under neutral conditions, this is like okay to leave. Not the best, but again, and if it was to kick off the nitrogen, we'd go back to the beginning where we'd have to go through the whole process again. So it's just a matter of equilibrium. So we're going to kick off our carboxylate here. And we're going to get an amide from this. So we get an amide, but we also get a carboxylate too. So we get the amide and the carboxylate. That's our final product for that one. I have one more problem for you. So in this one, we have an ester, we have acid, and we have water. What do you think is going to happen there? Well, we know that with esters, they are very vulnerable to being hydrolyzed. And under acidic conditions, it's just going for the front line. If it was just water, okay, it happened at a slow rate. But here we add acid, it's going to go. Okay, so that's exactly what happens here. This is going to be acid catalyzed. Hydrolysis of an ester, okay, to a carboxylic acid. So we expect our product to look like this. Carboxylic acid. Very simple. How does this mechanism go? Well, HCl will donate a proton to the water, and we're going to form hydronium. We're going to have a positive charge, and the carbonyl will simply pick up one of those hydrogens. We're going to form a protonated carbonyl. And now oxygen's angry. He's like, oh, hell no. Don't give me that positive charge. Give it to someone else. That's where water comes in. Water's an unsuspecting victim. Water's like, okay, I don't know what I'm doing. I'll attack you. Why not? Oh, shit. Now I have the positive charge. God damn it. So the OH kind of tricked the water into coming in by taking on its positive charge. And that's, what happens. Very sad, but 'tis life when you're just a simple little baby molecule. Okay, so now the water is going to commit friendly fire and give it to one of its friends, right? It's going to say, hey, water molecule down the street, I know we live in the same neighborhood, we're the same blood, but I hate you. I want you to die. Take my proton. Make my life better. So he basically scams him, and we're going to get a hydrate. Okay, and that water now forms our hydronium. This is acid catalyzed. Okay, so the next step is we want this ethoxy group to leave, so we need to first protonate it, right? We can't just kick it off because a negative charge isn't really possible in an acidic solution, right? You can't really have those really strong nucleophiles exist because as soon as there's a negative charge, it's going to find a proton and take it and hold it close to itself. So we need to protonate it first to leave. And that's exactly what happens. We'll just say HCl, it picks it up from that. So this poor sucker of a molecule, this poor sucker of an ethoxy group is the final loser here. Actually, wait, no it's not. OH gets in an argument with the protonated ethoxy. It's like, get the hell out of my house, woman. It's going to kick out the ethoxy group to make it ethanol. So we have ethanol leave, and we'll have a protonated carbonyl and an OH. So now the OH group, he was sad because he made his wife sad. He kicked his poor ethanol wife out. Ethanol's now on the streets all alone. He can't live with himself. He's very depressed. He's taking hardcore narcotics, methamphetamine. He actually kind of, methamphetamine actually pretty close to this poor molecule. I mean, if you think, or no, that's Sudafed. Methamphetamine looks like this. Okay, kind of close. I don't know. Benzene derivative. Anywho, so he's regretting his life choices. He's like, damn it, I need to reconcile my life. So what does he do? He's going to revert and deprotonate himself, really sober up, okay? So he's going to deprotonate that hydrogen that's leading him down, that hydrogen being his guilt. He's going to go to therapy sessions. Maybe he'll call his wife and say he's sorry, or his ex-wife. And simple deprotonation leads to the carboxylic acid. That is our final mechanism problem. Hope you guys enjoyed this video, those 3 problems, how to blast doing it. Have a wonderful day.